So very good evening, guys. Today we're talking about one of the very important concept in electric current IIT, that is Kirchhoff laws. So Kirchhoff laws are very important. Kirchhoff laws. So generally, when you have to use these Kirchhoff laws, the first question is that when you have to use these Kirchhoff laws. Already we have a equivalent resistance series and parallel is there. We are entering into these Kirchhoff laws. So when the problem is that generally, suppose take this circuit resistance. So take a circuit. This is plus and minus. This is R1. This is R2. Now easily we have to solve. So this is I1. So this is also I1. This is I1, and this is also I1. So there is no change in the current. So there is no change in the current means what, guys? That is R equivalent is equal to R1 plus R2. So directly we have to do this job. So easily we have to solve the circuit. When we have two more batteries is there, suppose let's see, guys, here. So this is one battery there and one resistance and one battery, and we have another resistance and we have another battery is also there. Now how to tackle the situation? That is the problem now. So this is R1, this is R2, let us say this is V1, this is V1 and this is V2. So that is the problem now. So the problem is very clear. When two batteries is there in a circuit, how to analyze the circuit, how to get the values of current, resistance, and potential difference on that particular resistance. So the answer for this one is that Kirchhoff laws. Generally, we have two types of Kirchhoff laws are available. Generally, we have two types of Kirchhoff laws. The first one is that KCL, that is Kirchhoff current law, and the second one is that KVL, Kirchhoff voltage law. So what is KCL? So KCL nothing but junction law. It is also called as junction law. It is also called as junction law. What is KVL? KVL also called as loop law. KCL is called junction law. KVL is also called as loop law. So first, let's see the first one. What is KCL? So what is KCL? So generally, guys, KCL, let's take an example. Taking an example which is already known to people. So simple example I am taking. This is R1 and another resistance R2 is there here. It is connected as a parallel, connected with the battery. Connected with the battery. So how much current here, guys? I1, I is the current here. So junction is there, it will be divided. Let us say I1 and I2. So once again it is come here. So this is I1, this is I2, and combined together once again we will get a I current. So I current. Now I have to implement the junction law for this point X. Let us assume this I want to implement the junction law for this point X and Y. So let's see at junction X, at the junction X, at junction X. So what you get, guys? What is the incoming currents? So the incoming current is equal. What is the incoming current? Write down incoming current. So incoming current is equal to I is the incoming current. So I is the incoming current. And what is the outgoing current? So write down outgoing current also. So outgoing current is equal to I1 comma I2. I1 comma I2. So according to junction law, sum of incoming currents is equal to sum of means sigma. Sum of incoming currents is equal to sum of outgoing currents. So which means I is equal to I1 plus I2 is equal to I1 plus I2. So this is the way we have to write down Kirchhoff current law. So let's say, guys, at Y, what is the answer for this? At Y. So let's see at Y, let's take it as at Y is the junction. At Y junction. Let's see, guys, at Y junction. So how to handle the situation? At Y junction, how to handle the situations? So let's see, guys, here. I is equal to I1 plus I2. So let's see Y junction. So in the incoming currents is equal to incoming currents. So incoming current what is I1 and I2. I1 and I1, I1 and what is outgoing current? So outgoing current is that outgoing current. So outgoing current is equal to I. So once again same rule. Sum of incoming currents is equal to sum of outgoing currents. What is sum of incoming currents? I1 plus I2. What is sum of outgoing currents? I. So this is an example for I1 plus I2 is equal to I. So like this we have to implement junction. So next let's say guys here now move on to KVL. What is meant by KVL? How to work with the KVL? Let's say guys KVL. How to work with the KVL? So how to work with the KVL? KVL means what? Loop law. KVL means what here? Loop law. So let us say this KVL loop law. So let's say second one loop law. So how to implement loop law? So how to have to implement loop law? So let's say guys here generally loop law. Let us take an example so that you will understood. So let's take this circuit. Let us take a battery here, and we have once again resistance under battery. We put a battery, no issue. Put your wish how many batteries you want to go. Put another resistance also here, no issue. So we put one battery followed by resistance. And we put also resistance here, no issue. So like this one circuit is. We design one circuit. Let us say this is a circuit. Let us say this is R1, E1. This battery is E2 and this battery is E3. So let us say R2 and R2. So I have to implement loop law. When you implement loop law, we have to remember four things, guys. We have to remember four things. What is the first thing? We have to remember four things. What is the first thing? So first thing is that so this is a resistance R and current is moving like this. And the observation also, the path which is moving, so the path direction, path, observer, observer. So the path and the current both are in same direction. So what is the voltage drop? The voltage drop I want to calculate, that is IR. So it is same direction. So current is moving in the direction and the observer also moving same direction. So what is the resultant of that? So V is equal to minus IR. Next, the second rule. What is the second rule is that so in the same resistance R, so current is moving in this direction, but observer path is moving to against the current direction. This is the path of observer. This is the path of observer path. So observer is moving against the current direction. Then what is the voltage drop I want to calculate? So voltage drop V is equal to plus IR. So very important. So when same direction is there, what is that? Minus IR. When opposite direction is there, what is that? Plus IR. Next third rule is that what is the third rule? So I am traveling for higher potential to lower potential. So this is higher potential. This is plus sign. This is minus sign. It have a potential difference of V. Now I want to move in this direction. So the observer the path is observer path. Observer path is that where I have to stop. This is the place I have to stop at. Here I stop. So where I stop at lower potential. So what is the answer? Minus V. So same thing. Fourth rule. What is the fourth rule? The fourth rule is that same. This is plus higher potential. This is minus lower potential. My path is like this. So path is like this. So observer. So this is observer. So observer. So what is the EMF of this battery is V only. So now where I stopped here? Now I stopped plus. Now I stopped exactly on plus. So when I stopped plus, so what is the potential drop? V is the potential drop. So like this we have to find out the potential drop first. The potential drop first. And same can I implement it for this circuit. Let's say guys I implemented what is the rules we have it. I implemented for this circuit. So four rules I am applying for this one. First we have to do is that write down the junction points. Let us say A and let us say this is B and this is C and this is D and this is E and this is F. So these are the junction points actually. Take any loop you wish. We want to take any loop. From the diagram we have to take any loop. Let's say guys I have to take A, B, E, F, A. So where I started? A I started. Where end? A end. So I have formed a loop. Now apply the rules here. We have four rules. 1, 2, 3, 4. Four rules is there. We have to apply the rules. So shall I go with A to B? So where I am traveling? So I am traveling in the form of clockwise direction. Clockwise direction I am traveling. So let's see guys here A to B. Suppose before that we want to divide the current first. We want to divide the current I. So come here. So this is I1. So this become what? I minus I1. So this is I1 guys. This here also I. Here also I. Now the junction is there. Junction is divided into what? I1 minus I1. So we have a problem. Let's check you people. Let's check you people. So what are the incoming current? I. What are the outgoing currents? I1 plus I minus I1. So cancel. Once again same. So incoming current is equal to outgoing current. Such a manner we have to divide the current here. So I1. This is I minus I1. Here also what guys? I1. Here also what? I1. For this point what you get? I will get. I hope people are understood. Comes now AB. So we're traveling A to B. What is the resistance? IR1. So what is the voltage drop here? IR1. But what is the sign? So observable path and current direction both are same. So what you have to put? Minus you have to put. Minus IR1. So because of what is the region? So the observable path as well as current direction is same. So I have to put minus IR1. Next what is that one? Next we have resistance. Resistance R2, R3 I hope. R2 had R3 already there. So we put R4 no issue. We put R4. So what is the current here guys? What is the first we have to find out the sign? Same direction. So current is traveling downward. So the path observer also downward. So both are downward. What is the meaning of it? Same direction. So same direction. What you have to put? Minus you have to put I minus I1 into what that guys? R4. So we get a potential drop. Once again. Next, E to F. I move on to the E to F. E to F. So what is the current guys? What is the current? I. What is the resistance R2? What is the direction? So path is moving like this and current also moving like this. So same they are going like this. So what is the value of that I? So I into R2. Next comes here guys. So I jumped from minus to plus. So what is the path here? FA. So where I have to stop? I stopped on the plus value. So what you have to put the sign? Plus sign. So what is the value of that? E1 is equal to what? 0. So this is the way we have to write down the loop law. So how we define what is the definition for loop law? What is the definition for loop law? So see guys, what is the definition here? Observe you people. So this is what guys? This is what? Decreasing potential difference. Decreasing potential difference. Decreasing potential difference, but increasing potential difference. So how to write down? Sum of the algebraic sum. We write down algebraic sum better. Why? Because it is a variable now. Algebraic sum of algebraic sum of increasing and decreasing potential difference. Algebraic sum of increasing and decreasing potential difference. Potential difference is stated as is stated as 2 coulomb. Is stated as 2 coulomb. So that is the way we have to find out the current. Thank you guys.